Hello Python friends, this is Professor John Gallaugher, and in this video we are going to discuss some of the more important issues to consider when choosing a board to run CircuitPython. Now I won't look at the hundreds of boards that are available, but I will cover a subset of boards that I hope you find interesting, and I'm going to mention some of the more important issues for newbies to consider. I'll also highlight some of the gotchas and common mistakes that are easy for beginners to overlook, including a few mistakes I've made myself, so let's learn big! Now, if you've been following the CircuitPython school videos, you know that we started with the CircuitPlayground Bluefruit, or CPB, and this was a great first board because it's loaded with features, and in our learning videos, we worked with built-in LED lights, buttons, capacitive touchpads, the light sensor, the accelerometer. We connected the board to potentiometers, servos, external light strips, and in the Bluefruit school videos, we learned how to control the board via Bluetooth and use a free app for control and color selection. So hopefully you feel that we've learned a lot. Now, the CPB was also a great beginner and educational board because the pins and pinout holes that are available on most microcontrollers are available in the CPB as these larger pads that allow us to easily make connections using alligator clips. But as you know from visiting CircuitPython.org, there are lots more boards besides the CPB, and one of the great things about CircuitPython is that it runs on all of the boards that you see here, and new boards are being added all the time. Now, I'm not going to exhaustively cover all of these boards, but I do want to show a small number of alternative boards and some of the reasons why you might choose one board over another. Now, in my physical computing course, after students have used the CircuitPlayground Bluefruit, they're migrating to the Arduino Nano RP2040 Connect. Now, at the time I'm recording this board is available for about $25 in the United States. This board is by the Arduino folks. Now, Arduino sells lots of boards, but most of the time when people refer to an Arduino board, they're referring to one like the classic Arduino Uno. Now, this is probably the most popular Arduino board at the time I'm making this recording, but it's not as powerful, it's bulkier, and it doesn't run CircuitPython. Now, Arduino does make lots of other boards, and many of these do support CircuitPython, and the Nano RP2040 Connect is different from this bulkier Arduino Uno. It uses a very powerful chip developed by the Raspberry Pi Foundation. That chip is called the RP2040, so it's the first crossover event between these two giants of low-cost electronics, Raspberry Pi and Arduino, and this chip is powerful enough to perform some low-level machine learning and artificial intelligence. Now, most boards by the Arduino company run the Arduino programming language. It's based on C++, and that's actually based on technology that's about as old as I am. It's not as beginner-friendly as Python. You can run Arduino programs that execute much faster than Python, but since Python is the most popular introductory programming language, CircuitPython can be a really good first choice for working with microcontrollers. Now, Python is currently the most popular programming language. Most computer science programs use Python as the first programming language they introduce to students. Python is used in all sorts of applications, including data analytics. In fact, all of the undergraduates at the business school where I teach have to learn the Python programming language. So I'm using the RP2040 board in my class because it also runs CircuitPython, and we can reuse the concepts that we've learned when we started coding on the CPB. Now, the Nano RP2040 is very small. It has Wi-Fi on it so that we can use this for IoT or Internet of Things projects that communicate over the web. Now, any CircuitPython boards that support Wi-Fi also allow you to do things like gather data on weather, sports scores, stock and crypto prices, and internet-connected boards can also report data over Wi-Fi. So, for example, you could use a magnetic switch to send a message whenever a door has been opened, or you can use a soil sensor to have a plant send a tweet or other message whenever it needs watering. Pretty cool. Now, at a very basic level, one of the most practical things in being able to access the internet in a board is that you can more accurately report and update the time. Now, while we've seen with CircuitPython on the CPB, we can count off seconds like we did with the time sleep function, but most boards don't have a built-in fully functional clock. But if you can access time over the internet, you can easily add clock features to your program. Now, the Nano RP2040 also has some additional sensors, a motion sensor to report things like orientation, double tap events, and fall detection. It has a built-in microphone, and it's got lots of expansion pins, 22 digital pins, 20 with PWM, and 8 analog, and if those things don't mean anything to you right now, we'll cover them in a future lesson. Just know that you can wire up lots of stuff to this board. Now, a few reasons why you might not want to consider this board. At the time I'm recording this, the Bluetooth on the board doesn't integrate with the Adafruit Bluefruit Connect app, so using Bluetooth in CircuitPython on this board isn't as easy as we learned in the CPB. There's also no STEMMA-QT connection port on this board. I'll describe that in just a minute. And there's also no pass-through battery charging. I'll describe that in a bit as well. Now, there are lots more boards than the ones that I'm discussing here, but just to give you a sense of the choices available to you if you want to work with CircuitPython, this next board that I'm showing is the Adafruit Feather RP2040. Now, at the time that I'm recording this board is available in the US for about $12. It uses the same powerful RP2040 chip as the Arduino that we just looked at. And this board has Feather in its name because boards of this size use what's called the Feather format. Now, this is a standard format for microcontrollers. It's a bit bigger than the Nano board format that we just looked at, but it's still pretty small. Now, feather size boards are really popular. There are a lot of feather boards. Most of them don't use the RP2040 chip that's in this one, but these boards are all the same size, and they more or less use the same standards for pins and connections. Adafruit has a great site with more information about feather boards, and also note that not all feathers run CircuitPython, so you want to be sure to verify that the board's going to run your programming language before you purchase it. Now, another big advantage of using feather boards is that the standard size and pin connection for these boards means that there are a lot of add-on boards that just plug into the feathers and offer all sorts of additional features. These plug-in add-on boards are called feather wings. Now, there are all sorts of feather wings that provide additional capabilities like running motors that you might use in robotics projects, or adding different sensors. There are wings that include built-in displays. There are ones that add Wi-Fi or Bluetooth capabilities. So you can search online to find examples of dozens of feather wings. Just double check with your vendor to make sure that the wing will work with the type of feather that you're using. Now, one really nice feature of this particular feather board is that it comes with this STEMMA-QT port. And it's worth taking a little bit of time to talk about STEMMA-QT because this is a really useful standard, but there are a few things about it that can be confusing. Now, this is a really easy to use connection scheme that will allow you to simply plug in devices to the board using a standard connection cable. Now, in these videos and in my class, we're going to be using STEMMA-QT to add things like a temperature sensor, a 12-pad capacitive touch sensor, and a gesture and proximity sensor. Sometimes you'll hear add-on boards like this referred to as breakout boards. Now, STEMMA-QT devices use a communication standard called I²C, written as the letter I, the number 2, and the letter C. Now, most microcontroller boards support I²C. That's just a communication standard between boards and add-on devices. But if you don't have a STEMMA-QT port like this, then to use I²C, you have to hook up 4 separate wires for power, ground, data, and clock. If you've got a STEMMA-QT port, you can plug in any STEMMA-QT breakout boards with this one connector that brings together all 4 wires. And not only can you plug in the devices with this cable, you can also daisy chain devices together so they can all share that one port. Now, STEMMA-QT is Adafruit's name for this standard. SparkFun calls the standard QUIC, that's QWIIC. The IIC stands for I²C, and SparkFun's QUIC standard only supports 3.3 volt devices. The Adafruit STEMMA-QT standard is a little more flexible. It supports 5 volt as well as 3.3 volts. Now, if you want to use a quick breakout board from the SparkFun company and you want to use CircuitPython, just make sure that there's a CircuitPython library to support that device. Also, even though this STEMMA-QT connector is really handy, it uses the I²C communication standard, and not all the things that we want to attach to our board use I²C. For example, if you want to hook up some hardware that we used in our previous lessons, like the NeoPixel light strips and strands, or the servos and potentiometers that we'd used in our CPB lessons, these don't use I²C, so they don't link directly to the STEMMA-QT port. A dead giveaway is that these devices used 3 wires, while the I²C standard that STEMMA-QT uses 4 wires. Now, in most cases, you'll hook up 3-wire devices like this NeoPixel strip using a breadboard. I happen to be hooking this up using an Arduino Nano RP2040 Connect, but I could do the same thing with a Feather RP2040. Now, the breadboard is this plastic rectangle that you see here with the pinholes in it. You insert header pins into these holes to connect up wires so that you don't have to solder. Also note that even though the Arduino Nano RP2040 Connect board doesn't have a STEMMA-QT port for STEMMA-QT breakouts, we're going to connect one to the board using a 4-pin wire connection that has a STEMMA-QT port on the other end. I'll show you how to do this in a future video. Now, one other thing that's easy to confuse, there's another standard, actually 2 standards called STEMMA, not STEMMA-QT. There's no QT at the end. And this system is not plug compatible with STEMMA-QT. And it gets even more confusing because the STEMMA standard has 2 different kinds of connectors, a 4-pin and a 3-pin standard. Now, here's what you need to remember. The 4-pin STEMMA standard is compatible with STEMMA-QT because both of these standards support I²C. You can use the STEMMA 4-pin with STEMMA-QT if you have a special adapter cable. And there's also a 3-pin STEMMA that's not I²C devices, so it doesn't work with STEMMA-QT. Now, if this is confusing, just make sure that you buy breakout boards that are specifically STEMMA-QT with a QT at the end if you want them to work with the standard STEMMA-QT port and the standard STEMMA-QT wiring. I've made the mistake of buying devices that were just STEMMA devices and not STEMMA-QT devices, and they didn't work with the port and wiring I wanted to use them with. Now, another reason why you might want to use the Feather RP2040 board is that it comes with a JST jack. This is the standard jack that's used for hooking devices up to rechargeable LiPo batteries, and even better, this jack provides pass-through charging, so if you plug the board in over USB, any LiPo battery that's plugged in will automatically recharge. Now, pass-through charging is convenient because it means that you don't need to buy a separate battery charging board. It's also nice because you can often plug a battery into your project, never worry about disconnecting it, and this is an advantage because JST connectors are sometimes tough to unplug, and it's really easy to accidentally break off these wires. Now, if you do use LiPo batteries, they're chemically flammable and they can be dangerous if they're punctured, so you should definitely do some research online before working with them, but they're very popular and they can be a good choice if you know the risks and you're careful. So some of the pros for the Feather RP2040 include small size, although it's bigger than the other two boards that we're going to be showing. It's got the STEMMA-QT port that makes wiring and expansion super easy. It can use many of the Feather wings for expansion as well, and it has pass-through LiPo battery charging. Now, this particular Feather board, it does not include Bluetooth or Wi-Fi, so it's not the choice for Internet of Things projects. And even though it's small, it's larger than the other boards we'll look at. Now, this last microcontroller board that I'm going to show you is the Adafruit QT Py RP2040. They call it the QT Py because it's got a STEMMA-QT port and it runs CircuitPython, and RP2040 because it still uses that super powerful chip that's available in the other two boards that I showed. Now, this is super tiny. It's the smallest board I'm showing. It's also the least expensive. At the time that I'm recording this, it's available for less than $10 in the United States. Now, the board doesn't have wireless capabilities. It's not a Feather board, so you can't use the Feather wing expansion options, and it also doesn't have a JST battery connection. Although, if you're comfortable soldering in small places, it is possible to buy an expansion module that has to be soldered onto this board, but it would allow you to use a super tiny board that's battery powered for portable projects. When choosing a board, another lesson that I've learned the hard way, make sure that you check the type of USB port that the board uses. So the Feather RP2040 and QT Py RP2040 use the newer USB-C style ports, so you might need a new cable with these boards. The CPB and the Arduino Nano RP2040 Connect use older micro USB style ports. Also, always make sure that you're using a data cable and not a charge-only cable. If you use a charge-only cable, your device won't show up on your computer. Now, all the boards that I've showed you up until this point are microcontrollers. That means that they run one program at a time, and they aren't running an operating system. Now, later in the course, we're going to be using Raspberry Pi boards, which are often considered real computers because they can run an operating system and they can run several programs at the same time. Now, Raspberry Pi boards are more difficult to set up. They have additional advantages, including lots more storage. That's great if you want projects that require storing large files, like audio files. These boards usually have more expansion ports and capabilities. Some old-timers might tell you that a Raspberry Pi is a computer and microcontrollers aren't. Microcontrollers run programs, they compute, I call them computers. The main difference is even though a Raspberry Pi is tougher to set up, it's a bit more flexible, expandable, and it can act as a desktop computer. Microcontrollers are great for special purpose projects, for creating smart hardware projects, and these are sometimes referred to as embedded systems projects. Now, also know that a Raspberry Pi can run CircuitPython. All we need to do is add an additional software layer called Blinka. There are videos on how to do this on my site, and I'll also cover this more in future sessions. Now, also when buying boards, pay attention to whether or not the header pins are on the boards. Now, sometimes there are no headers on the board. Other times the header pins are included, but you have to solder them on yourself. Other times the boards can be purchased with the header pins already soldered on them. And you likely want the header pins installed on your board if you're going to be using the board for learning and you're going to be using a breadboard. Now, why wouldn't you want headers installed? Well, if you wanted to keep the device flat, so you usually use a board without headers. If you're creating a final project, you can solder the wire directly to the pinholes instead of having to work with the pins. It is possible to desolder header pins if you've already got them soldered to your board, but it's actually pretty tough to desolder header pins after the fact. It's not really something that a new student wants to do, or even a seasoned maker for that matter. So pay attention to see if headers are included with the board that you're ordering. I actually didn't pay attention to this, and I initially ordered 70 Arduino Nano RP2040 Connects that did not have the headers, and I did want the headers, so I had to send back all of those boards and exchange them for boards that did have the headers. So that's it for a quick comparison of the issues that I think are most relevant for my students. There's a lot more to the differences between these boards, but hopefully you thought this was a good intro and you're armed to be able to explore more information online if you need to. Have you got a favorite CircuitPython board or additional advice for newbies? Leave it in the comments below. Just don't be snarky. Nobody needs that. Now in the next video, I'm going to show you how you can install CircuitPython on these various boards, use the REPL to show what pins are available, how to refer to these connection pins in our code, and how to look up additional board information online so that we can begin to understand how to connect devices to these boards. Keep at it!